Hi everyone, welcome to Applied Physics lecture series. So I'm Dr. S. Deepthi, Assistant Professor in Physics, Department of HNS, MLR Institute of Technology, Hyderabad. Today our topic is lasers. So this is the overview of lasers. So we are going to see about the introduction of a laser, next characteristics of a laser, next absorption and spontaneous emission and stimulated emission of lasers. These three topics we are going to see about lasers. So, see here, laser stands for light amplification by stimulated emission of radiation. Light is emitted from sources when the atoms makes transition between higher and lower energy states. So, see the diagram over here. So, laser light differs from ordinary light. Laser light is a monochromatic, directional and coherence. We'll see in later slides about all these ones. So ordinary light, what is the major difference that we can observe from this diagram is this diagram consists of a laser light, that is the laser consists of a single color and ordinary light consists of so many colors, as we can see mixture of colors. So laser light is a pointer light and ordinary light travels in all directions. So laser light is a coherent and ordinary light travels with different forms of waves. This is about a introduction of lasers. Next, let us see about the characteristics of a laser. What are the characteristics of a laser? These are four characteristics. First one is high directionality and less divergence. Next one is high monochromacity. Next is high coherence. And final one is high intensity. Let us see in detail about all these slides. So first, let us consider the high directionality as less divergence slide. So that means this is one of the characteristics of a laser, that is an important characteristic of a laser. So ordinary and laser directionality. So this is the directionality of laser that extends from 2 kilometers, that extends to 2 kilometers here. In this, the torchlight or whatever the light may be, the light shown here is having 2 kilometers of range. And what about laser light that we can observe? Laser light is a highly directional. So that means it travels in one direction, it is not extending it towards any source, it travels in one direction. So in conventional light sources, lamp, sodium lamp or torchlight, so the photons will travel random in direction. Therefore, these light sources emit light in all directions. Next, in laser, all photons will travel in same direction. Therefore, laser emits light only in one direction, single direction. This is called as directionality of laser. The width of laser beam is extremely narrow. Hence, laser beam can travel through long distances without spreading. This is as shown in the figure. So, as we observe in the figure, without much spreading, the laser light travels. Next, coming to highly coherent. So, this in ordinary light sources, lamp or sodium lamp or torchlight, the electron transition occurs naturally. So let us consider the electron transition in further slides. So the photons emitted from the ordinary light sources have different energies, frequencies, wavelengths and colors. So this is an ordinary incoherent light. They have different colors, frequencies and energies and wavelengths. So comparison. Next, going to laser light. In laser, the electron transition occurs in specific time. So the time bound we are keeping in a specific time. All the photons emitted in a laser have same energy. We need to keep that in mind. They have same energy, frequency or wavelength. Hence, the light waves of laser light have a single wavelength or color. Next, high monochromacity. Monochromatic light means light containing a single color or wavelength. Okay. As we can observe from the previous slides. In the previous slides also, we have observed the single color. The photons emitted from the ordinary light sources have different energies, frequencies, wavelengths and colors. Hence, the light waves of ordinary light sources have many wavelengths or colors. Therefore, ordinary light is a mixture of waves, have different frequencies or wavelengths. So, here also we are going to compare about the ordinary light with the laser light. On the other hand, in laser, all the emitted photons have same energy, frequency or wavelength. Once again, the statement came. That means whenever we think about a laser means the light which is having same energy, frequency or wavelength. We need to keep that in mind. Hence, the light waves of laser have single wavelength or color. Therefore, laser light covers very narrow range of frequencies or wavelengths. So, see here in the figure we can see the sunlight with multiple frequencies, it is a non-coherent. And incandescent bulb, this is also a single frequency non-coherent, whereas laser light single frequency and coherent. So sunlight is having multiple frequencies, whereas our incandescent bulb or normal bulb will be having even though it is having single frequency, the waves will be coming as non-coherent waves. Next, laser source is a single frequency and coherent wavelength. So, high intensity. The high intensity of wave is energy per unit time flowing through the unit normal area. So, that is about the intensity of a wave, the energy per unit time. This is the energy per unit time flowing through a unit normal area. In an ordinary light source, the light spreads out uniformly in all directions. If you look at a 100-watt filament from a distance of 30 centimeters, the power entering into your eye is less than 1/1000 of a watt. Okay. Whereas what about laser? In laser light, the light spreads in small region of a space and in small wavelength range. Hence, laser light has greater intensity when compared to the ordinary light. This is the picture that we can observe about the laser light. We can see laser shows the laser beautiful colors will be we'll observe the beautiful colors. So watch that one. So each and every laser light will be coming out to show in a laser show. Okay, we will observe beautiful colors like this. Next. So, coming to the absorption, spontaneous emission, stimulated emission. Here the slide is like this. So, what about it? So, we have already learned about, till now we have learned about what are the characteristics of a laser. The characteristics of a laser are, once again, high directionality and less divergence, high monochromicity, high coherence and high intensity. So, directionality means single direction. High monochromicity means light having single wavelength. Highly coherent means the waves that are traveling. The waves means like this, the waves will be represented. The waves that are traveling having zero phase difference or constant phase difference between them. This is known as coherence condition. Okay. Zero phase difference or constant phase difference between them is observed, which is known as coherence. So, the laser light is a highly coherent and high intensity. Since the laser light is very thick in nature, so that it is very intense. It is having very intensity. So, these are the four characteristics of laser. Now, we are going to observe how the production of laser light. What is laser? Laser means light amplification by stimulated emission of radiation. Okay, the full form of laser is light amplification by stimulated emission of radiation. I have given definition in the first slide. So, see here, for a laser to come, we need to get the stimulated emission of radiation. So, in order to get the stimulated emission of radiation, let us first consider what are energy levels. So, energy levels means let us consider an atom. An atom consists, what does an atom consist of? An atom consists of nucleus surrounded by different orbitals. And the electrons will be setting in these orbitals according to the Auber principle. Okay. So, these are known as energy levels. So, energy levels means the levels that the electrons exist in a atom. These are known as energy levels. So, the electrons that are bound to the nucleus are said to be in the first level or ground state, are closer to the nucleus. The energy levels that are closer to the nucleus are known as ground energy levels, and the energy levels that are far from the nucleus, like this, far from the nucleus, that are known as excited energy levels. Okay. So, this is about energy levels. So, if we consider any atom, the atom consists of a nucleus and surrounded by the electrons revolve in different orbitals. So, these electrons are arranged according to the Auber principle. So, whenever the electron is there, the electron will be moving around the nucleus and it will be jumping from one energy state to another energy state. Okay, these are all quantized energy states. Okay, these are known as quantized energy states. So we have just got an idea about energy level. Now let us consider two energy levels. We have so many energy levels. Even though we have so many energy levels, let us consider two energy levels here. That one is first one is the lower energy level. Second one is the higher energy level or excited state. That means the state closer to the nucleus and the state far away from the nucleus in our general language. So see here, another one is, here we are telling about an atom. So if we consider the atomic transition, the atomic transition means the electron that is going to transit from one energy level to another energy level. Then the total is considered as atomic transition. Okay, so consider two energy levels E2 and E1, where E2 is the higher energy level as we have said and E1 is the lower energy level. So the radiation interacts with matter by the three processes such that the transition between the two levels is occurred by absorption, spontaneous emission and our stimulated emission of radiation. Now absorption means when the atom is in the ground state. Atom means the electron is in the lower energy state. We are going to consider the whole atom. Okay, is it clear? So the atom in the lower energy state. Then if an energy of photon is going to give to the atom, okay, if an energy of photon is provided to the atom, then the atom will be going into the upper energy level. Okay, the atom will be going into the upper energy level. Then what happened there? The atom stays for some time and returns to the ground state by releasing the photon of energy. This is the second diagram. This is known as spontaneous emission. First, the atom absorbed from lower energy state to the higher energy state, and then the atom stays in the higher energy state for some time and then returns to the ground state. So the amount of atom that is absorbed from the lower energy state to the higher energy state is known as stimulated absorption. Stimulated means the energy will be provided from outside. If the energy is provided from outside, that is known as stimulated. So the stimulated absorption. Next, spontaneous. Spontaneous means at the moment. Okay, as we know about the spontaneous, the definition of spontaneous. So we can know that spontaneous means at that moment. When an atom is in the excited state, returns to the ground state, then that is known as spontaneous emission. And what do you mean by stimulated emission? The third one is stimulated emission, where the lasers come into existence. So when the energy of a photon is given to the atom which is in the excited state. Okay, the atom, if the atom is in the excited state, if a photon of energy is given to the atom which is in the excited state, then the atom comes to the ground state after a period of time and by releasing some amount of energy. Okay, so this amount of energy will be in the form of photons, in the form of radiation, and it is having same direction. Okay, the photon will be released in the same direction. This is known as stimulated emission of radiation. So now in detail of stimulated emission of radiation. The atom is in the excited state E2 if a photon of energy is incident on it before the completion of its lifetime. As I said earlier, what is the lifetime? Lifetime means the staying of atom in the excited state. The time that the atom spends in the excited state is known as lifetime. Okay, so the lifetime of this photon stimulates from the even E2 energy level to E1 energy level, then the photon of energy H releases along with the incident photon. These two photons will have now same energy, frequency and are in the same phase. Same phase means and are in coherent with each other. This phenomena is known as stimulated or induced emission of radiation. Okay, so by this we can have an idea about how the laser is produced. How the laser is produced? By stimulated emission of radiation. Stimulated emission of radiation occurs whenever the atom in the ground state rises to the higher energy state. Then the atom stays in the higher energy state for a period of time. That is known as spontaneous emission. That is for a period of time. If that atom is provided with a photon of energy, then by taking the photon of energy, it will release, it will stay up to some time in the excited state and come to the ground state. This is known as stimulated emission of radiation. And finally, we are going to have the two photons having same energy, same frequency and are in coherent with each other, so that laser will be produced in this manner. Okay, this is about lasers. So what we have learned today? We have learned about how the laser is produced and what are the characteristics of lasers. So this is about the introduction of lasers. Thank you.